Conditional statements. So conditional statements are a way for mathematicians to be consistent in showing what causes what. Because often mathematics is about we're given some information and we're trying to figure out some other thing. So conditional statement is a statement of the form if, then, then. So if some sort of hypothesis, and you've seen that word in biology, it means something slightly different here than conclusion. So if something happens, then something else happens. And occasionally we'll extend this to a justified conditional statement. So if something happens, then something else happens because, and we have a reason. But for the most part, we're going to be focusing on the conditional statement without the reason for today. Here's a straightforward conditional statement. If A and B are negative, then A times B is positive. So this is a statement about if you have -2, -3, those are both negative, then -2 times -3 is positive. Great, that's true. -2 times -3 would be 6. This happens to be a true conditional statement. You can write a conditional statement that is false, but this one happens to be true. So if we want to rephrase this into conditional form, what we do is we have an if and we have a then. And what's causing what? Is kissing you causing hell to freeze over? No, it's really hell freezing over causes the kissing. So if hell freezes over, then I'll kiss you. Okay, so that has our hypothesis is hell freezing over. Conclusion is I'll kiss you. Rephrase into conditional form. Put your phone away or I'll take it. Is putting your phone away causing the taking? No. Not putting your phone away causes the taking. If you don't put your phone away, then I'll take it. Yeah, this has the same meaning as that sentence. X equals 2, so x squared equals 4. If x equals 2, then x squared equals 4. And that's true. You can square both sides and then get x squared equals 2 times 2 is 4. Great. So we have ways of changing conditional statements from our original if x equals 2, then x squared equals 4. The converse of that statement is to switch these. So this part switches with that part. So if x squared equals 4, then x equals 2. And this one happens to be false because x could be -2. But that's what the converse is. This is the converse. The inverse is when we take the original statement and make it opposite. So instead of x equals 2, we say x is not equal to 2. Then x squared is not equal to 4. And this also happens to be false. But that's the inverse. And then the contrapositive, fun word, contrapositive is when you do both. You switch the order of the statements and make them negative. So if x squared equals 4, well, instead of x squared equal to 4, we'd put not equal to 4. Then x is not equal to 2. And this one happens to be true. So this is the idea of contrapositive. You should know which one is which. Likely a question would be something like, which of these is the converse of if x equals 2, then x squared equals 4? So the definition of conditional, if-then, converse, switch, hypothesis, and conclusion. For the inverse, negate, hypothesis, and conclusion. And switch and negate. A counterexample. Well, it's an example that is counter or against something. So an example that proves something false. You cannot prove something false. Or sorry, an example cannot prove something true. It can disprove, but it cannot prove something to be true. So here I said that this was a this was a false statement. And the counterexample to that bolded statement is x equals -2. Then x squared equals 4. So this is a counterexample. You could just say x equals -2 is a counterexample to that inverse statement. So the students who are struggling come to tutoring. If a student is struggling, then they come to tutoring. Yay. Now we're going to write the converse. Well, converse was switching. If a student comes to tutoring, then they are struggling. That's not necessarily true. It's often the case, but not always. It doesn't have to be. You're certainly welcome to come to tutoring, even if you're feeling comfortable with the idea. If a student is not struggling, that would be the inverse. I put in not. Then they do not come to tutoring. That would be the inverse. The contrapositive is to switch both. So if a student does not come to tutoring, then the student is not struggling. There we go. So that's the contrapositive. This comes up in geometry with statements like, if two lines are parallel, then they never intersect. This is a true statement, and the opposite is not true. The converse is not true, that if two lines never intersect, there could be a different relationship besides just parallel. But this is why we care, because we want to be able to write sentences like this and understand what we're talking about. Last thing you need to know is a biconditional. When both directions of a statement are true, a polygon has three sides if and only if the polygon is a triangle. So if a polygon has three sides, then it's a triangle. Also, if the polygon is a triangle, then it has three sides. Thank you.